we'll do those two. Make sure you're paying attention. Phones are put away. Okay. For number 1, this has 4 terms. So if we're thinking of our different factoring methods that have 4 terms, there's only one. The factor by grouping, where we split this down the middle. Find the GCF of these two. You can either list out all the factors of 20 and negative 16, or use your calculator, go into math, over the number, down to GCD, and put in 20 and 16. And 4 would be that highest number. And then these also have ends in common, and you look at the lowest one, so I can pull 2 ends out of both. Remember that we're dividing this from both. So if I divide that from both, 20 divided by 4 gives us 5. I took 2 of the ends away, so I have 1 left. Negative 16 divided by 4 is negative 4, and I took both ends away, so there's nothing else left. And then I do the same thing for the second set of numbers. Find the GCF of 60 and 48. I think it is possible. And I'm dividing both of these by 12. So when I do that, 60 divided by 12 is 5, and then I bring down the end. Negative 48 divided by 12 is negative 4. Our end sides are the same, so that's going to be one of your sets of parentheses. And I bring down everything else. Normally this would be the end, but when I look at this, I could divide something else out of this. What could I divide out? 4. So if I divide both of these by 4, I could rewrite that as 4 times n squared plus 3, 5n minus 4. And now nothing else can be factored out. So that would be your final answer. Questions there? Okay. In number 2, we are solving the following equation for b. This equation should look familiar as we just got done with quadratics. That is your quadratic equation. So if we're trying to get b by itself, we got to get rid of everything else. We can subtract c and subtract ax squared really at the same time. We have y minus ax squared minus c equals bx. We subtracted it to the other side, but it's not combining with anything. Then to get b by itself, we have to divide this by x. And because this would simplify, we're going to divide separately. So that b would equal y over x minus ax, because one of the x's would cancel, minus c over x. Or you could combine the y over x and the negative c over x. Y minus c over x minus ax at the end. And then that would be the equation solved for b by itself. Question on that? Other questions we want to see on the chart right? Okay. Look at the course calendar. All of this unit is going on quarter 4, so these will be the first grades of quarter 4. There'll be a Delta Math that'll be due on Friday on what we do today. That'll be in quarter 4. The quiz, the test will be in quarter 4. So when we get back from spring break, we have a full week, and then the following week we have that Monday and Thursday, Friday. And I would only see you guys that Thursday. But the full week, we have the quiz, and then the test when we come back that 3-day week, and then your flex day after that. So I'll send out notifications like I usually do, but just keep those dates in mind.
All right.
And,
Pretty much.
but I don't remember. Questions about anything dates-wise? Usually the last test is due by the next test, but because the end of the quarter is the 8th, the Unit 7 test has to be done by April 3rd. So the week we get back from spring break, that needs to be done by then. Retake work also needs to be done by April 3rd. You could retake April 4th as long as everything is done. So keep those important dates in mind, April 3rd and April 4th, as those are slowly approaching. Okay, look at your notes. I need all cell phones put away. Alan, do you record the computer? So this next unit is about transformations, which is going to be new to you, but something those of you going on Algebra 2, something they'll cover in the beginning of 1 or 2 units. Some of what we talk about today is going to be very familiar to something we've already seen, things we've already seen. Domain and range, different notation, and how we use that on a graph. Alright, so first we're going to rewrite what's given here is set builder notation. You've seen that with our inequalities. We're going to rewrite this into interval notation. We talked about that with our inequalities and a bit with our quadratics. I'll write this note and you can write it if you so choose. Your interval notation is your parentheses and brackets. And that's for strictly less than, strictly greater than, or if it goes to infinity, negative or positive. Your square brackets if it's less than or equal to or greater than or equal to. If it helps you, you could draw a number line, but there won't be one. You'd have to visualize it. So if I were to write x is greater than negative 3, and interval notation is greater than, so we're going to be using parentheses, we have to think about where would that start and where would that end. If it's greater than negative 3, it's going to start at that number. So start at parentheses, negative 3. And then if it keeps going, everything greater than negative 3, it would keep going to infinity. And infinities get parentheses. So these say the same thing, just in different formats. Questions about that? Okay, so let's try a different one. X is less than 8. Again, we're using parentheses. If it's less than 8, we're looking at where would that start on a number line looking left to right. If 8 is somewhere here, everything less than that, it would keep going to the left to negative infinity. So it would start at negative infinity, parenthesis, and this one would end at 8, also parenthesis. Questions so far? This one, the next one has equal to in it, but it's facing the same direction as the last one. So where would this start? negative infinity. That one's going to be a parenthesis. Infinities, negative infinities, always parentheses. But it ends at 2, and that's going to be a square bracket. So then how would we write the next one? We can start at 0 with parentheses or square bracket, and end at infinity. Because of the equal sign. So anytime we have the equal sign, we're going to use that square bracket. Okay. Pick any others from this that we want to see do go over before we jump to the bottom section. Which one? 3/8. Okay. Any others in this? Oh, this one. Okay. Those work the same way. You just write them as decimals or fractions instead. So this is x is less than 1.5. Where does that start? That's where it would end. So with everything below or less than 1.5 is going to start at negative infinity. And then end at 1.5. Would that be parenthesis or bracket? Parenthesis, because it doesn't have the equal to. Okay. What about the other one? X is less than or equal to negative 3/8. Where would that start? That's where it would end. Is it similar to this one? Negative infinity. And then ends at negative 3/8, parenthesis or bracket. Do you have any questions on how we go from set builder to interval notation? Are there any others in that section we want to do? Right. The next section you're doing the opposite. Now these are in interval notation, and we have to put it in set builder notation. The set builder notation here is kind of missing this. You won't need to do all of this, but you may see it later on. I'll do one like this, and then we'll do the rest like this. So for this one, let's say these are all x values. I'm going to draw curly brackets. Write x, just draw a vertical line. And then, as I'm looking at this, these are both parentheses, which means they would be less than or greater than. But because I have two whole numbers, that means it starts at one and ends at the other. So this would look like negative 6 is less than x, which is less than 4. And then I would end it with curly brackets. So we didn't see that for any of these. But pretend that it's there, because you may see that later. It's just a straight vertical line.
Why is there only one trait?
Say that one more time.
Why is there only one?
That's the way it's written. So I don't think I have some in this specifically, but you'll see it elsewhere where it looks like that. But don't you be surprised. Alright, so if we weren't using the curly brackets and all of that, we would just write what's inside here. 6 is less than x, which is less than 4. You always use less than or less than or equal to's if you have two numbers. Never greater than, because you could really read one backwards. Questions on that? So this only applies if you have two numbers. If you have infinities, then it's going to be something similar to what we had up here. So I'm not going to write the curly brackets. You can continue to if you so choose. This starts at negative infinity and it ends at 5. So would that be everything greater than or less than 5? Less than. And this is a parenthesis, so it's strictly less than. So x is less than 5. So those are the questions you have to ask yourself when you see something like this. Questions so far? Yeah.
Would you not put a parenthesis over that?
So we're not doing this, what we did up here, we're doing the opposite.
Okay.
So we're writing it like this. Like what was already given. Okay, we'll do one more and then it'll be time for lunch. So this next one has two numbers. It starts at -2, it ends at 2. This is a square bracket, so that's going to be less than or equal to. So -2, less than or equal to x, which is strictly less than 2. The signs depend on the parentheses or brackets. Right, we'll do some more of this when we get back to it. Do we have questions on the 3 we've done so far? We're going to do one more, and then any of you guys want to see do go over. Let's do this one. We'll skip this one and do the 8 to the infinity. So, 8 to infinity, it is going to infinity. Would that be greater than 8 or less than 8?
Less than, or greater than 5.
Greater than. And then because of the bracket, would that be strictly greater than or greater than or equal to?
Equal to.
Equal to. So that would be x is greater than or equal to 8. Questions on that? Any others in this section we want to see you go over? Have questions about? Yeah.
Parentheses. Bracket.
Okay. Any others? Here. One with this one. Okay. So then you're gonna. Okay. Alright, let's do the 2 infinities first. This one's a weird one because you won't normally see this. But this is called, all real numbers would be included in this. It starts at -infinity, it ends at infinity. So to write this in set builder notation, you're going to write x, this weird looking e, like a 3 but backwards, and then a capital R with another line in it. This is the same thing as this. It just means that all numbers that you know, decimal fractions, negatives, positives, everything in between, is part of this. Starts at -infinity and goes to infinity, everything in between. So anytime you see something like that, write that. If we have to.
23.
It really reads x is an element of all real numbers. It's a E for element. But it just means the same thing. Okay. The 7 to 8 is between 2 numbers. We're going to start at 7. Would this be less than or less than or equal to? Less than, because of the parentheses. X less than or equal to for 8. Less or less than or equal to is what I'm going to say. Equal to. Less than or equal to 8.
So technically, whenever you have like 2 numbers of arrows for the same color,
Yeah.
all the time.
All the time. Any others in the section? This one?
Yeah.
Okay. So we know it's going to look like this. Are we going to have less than or equal to? Less than for both of them. So 1 is less than x, which is less than 2. Any others? So now that we get the general gist of how to write it, now we're going to actually use this in problem. So go on to the back. Some of these are a little bit hard to read, so if you want to write over them, write bigger, highlight, feel free to do that. So previously, when we were doing our quadratics and talking about domain and range, I briefly mentioned that domain is your x values. That's still the same. And it's your x values looking from left to right. Kind of like what we were just doing, thinking about it left to right. Your range is your y values. And you're always going to look lowest to highest or bottom to top. You don't have to write both, but whichever one is going to help you remember that. So in each of these different graphs, we have to talk about domain, range. We'll talk about increasing, decreasing, constant in a moment. So if it helps you, these draw the ceiling group walls. That would be draw any highest points, a line for the highest points, draw any lowest points, a line for the lowest points, and draw any, like if you have endpoints, vertical lines where those would be. So in this case, I have arrows at the ends of these. So those are going to keep going forever and ever off the graph, off the page. So you have to imagine that. But this doesn't keep going all the way down. It has a stopping point. That would be like your floor. So domain, we're looking left to right. If I'm thinking about this, if this were to keep going to the left, where would that start? Negative infinity. It would keep going up and left into the negative values to negative infinity. And then if we're looking to the right, this has an arrow. It's going to keep going up and right forever and ever off that way. Where would that end? Positive infinity. So you can write it like this, or x is an element of all real numbers. So either or. Questions on how we found the domain first? Range, lowest to highest. So here, because this has a lowest value, that's going to be where we start. And because we don't see like a hole or an open circle, we have to assume that's included. So that's going to be a square bracket. Start at -2. And as I keep going up, where does that end? Infinity. So if we were to write this in set builder notation, range is y value, so we would put y here. Would that be greater than or less than -2? -2 to infinity. Would that be above or below -2? Is greater than. And then would that be greater than or equal to? Greater than or equal to. So I'm writing it in both so you see both ways of writing it, because it may tell you to write it using interval notation or set builder notation. You have to be able to do both. Questions on range? Okay. Increasing, decreasing, and constant is a little weird. So for increasing values, you're looking at the x values. We're going to write the x values, but we're also looking at what is the y value doing as you're looking at the x values. So as I'm looking left to right at my x values, here, along this line, if I keep going to the right, my y values start to go down. Because when x is 0, y is at 4. When x is at 1, y is at 2. When x is at 2, y is at 0. The y values are going down. So that means that would be a decrease. The y values are going down as the x values keep going to the right. I'm going to write that as a side note. So as the x's keep going up, or to the right, to the right, the y values are going down as you move to the right. Increase is the opposite. As you keep going to the right, if your y values are also going up as you go up, or your x values go up, that's increase. So if it helps, draw these little arrows. As I keep looking to the right of my x values, what is my y value doing? Look between two different points. Look and see, okay, my y value was here, now it's here, so it has to be going down. So then when we write the increasing, we're looking at where does it start increasing. So I'm going to draw a line at this point. Wow, that was really crooked. Try again. Because this is where it starts to increase and stops decreasing at the same time. So if we're looking for increasing, it would start at x value of 3. And where does it stop increasing if this line keeps going? Infinity. If we were to write that in set builder notation, we're going to use x because we're writing our x values, but looking at our y values. Would this be greater than or equal to, less than or equal to 3? Greater than or equal to. So x is greater than or equal to 3. Everywhere from 3 on, your y values keep going up. It's increasing. Questions on that before we do decreasing? Okay. So this arrow means it just keeps going out. But we're focused on the red arrows. This stops at 3, but where does this start? Negative infinity. We said it stops at 3, again bracket, and then basically this would be the opposite. X is less than or equal to 3. What's nice about increasing, decreasing, and constant is that it should go from one to the other. So here I'm decreasing until this part, and then I start increasing. And then if that is everything, so this keeps going to infinity, that goes to negative infinity, there would be no constant. Or you could write in it. None, not applicable, doesn't exist. Just don't put 0. That would mean it's constant at 0. Any questions on how any of that works so far? Let's do this one, and then I'll let you guys choose some. We'll do another one, and then I'll let you guys choose some. Right. Domain. We're looking at this. I'm going to erase part of this. This has arrows at the end. They're just very, very tiny. We're looking at this left to right. You have to imagine this keeps going down and left, and down and right. So where would this start? Where would this end? So it's going to go past that point. Where would this one start on your x values if this kept going down and left? Negative infinity. And where would that end if that kept going down and right? Positive infinity. Your range is going to be kind of similar to the last one, except opposite. This has a highest point, but it keeps going down. So if we're looking lowest to highest, where does this start? Negative infinity. And then what is the y value right here where it stops?
0.
0. So would that be greater than or equal to, less than or equal to 0? Which of those four? Is it above 0? Is it below 0? It's below, so it would be less than or equal to. But it's a bracket. So less than or equal to. So y is less than or equal to 0. Those are the same. Okay, I'm going to draw in the arrows. As I'm looking at this, and I'm going to rewrite these numbers so we can see them bigger. As I'm looking at this left to right, I keep going to the right. My y values are doing what here? Say that again, John. The actual what? Right here. Yeah, that's at 1.5, but we'll talk about that later. What did you say? It's increasing. Your y values are going up. And then after that, what happens here? What are your y values doing? They're decreasing. They're going down. So increasing would start at what x value if this keeps going down to the left? Negative infinity. And it's going to stop increasing at that 1.5. So then where is it decreasing?
Is it negative or positive?
The infinity is going to be positive if you're looking at your x values. So 1.5 is where it starts. And then if we kept going down and to the right, we keep going to the right with our x values. Again, this starts at negative infinity, it goes to 1.5, this starts at 1.5, goes to infinity, so there's no constant. We're going to do one with a constant. Now, the ones that have arrows are different than the ones that have endpoints, because those are just going to be, it stops at a number, not infinity. But we're going to skip down to the bottom. And do this one. We're going to ignore this. I'm not going to change that. So this one's not asking about domain and range, because that's an algebra 2 topic, because it's two different things. But as I'm looking at this left to right, we're going to ignore this first part. What are your y values doing here as I'm looking left to right? They're increasing. I feel like this was an open circle, so we're going to do parentheses. At -2, it It starts at -2 and stops increasing where? Positive infinity. We keep going. Is there anywhere where your y values are going down? No. So it's not decreasing at all. And then constant would be, as you're looking left to right, your y value is staying the same. So that would be this one. It starts at where? So it ends there. Where does it start? If it keeps going up. Negative infinity, stops at -2. That one I think was close. So square bracket. So constant is only used if you see a straight horizontal line. If you see a vertical line, that is not constant. Questions on that? Any other questions we want to go over on this page? They're not numbered, but if you tell me what it looks like or which one it is. One above this one. Is this one's a weird one? Alright, if we're looking at domain of this, left to right, I see this has a stopping point to the left, but it has arrows to the right. So if I'm reading this left to right, where does this start? Where does this stop? Yes, -4 to positive infinity. This would be a square bracket. Your range, so usually our functions look like this, where they're up or down, not sideways. So now if we're looking at range, this keeps going down and right. This keeps going up and right. So what's the lowest point and what's the highest point? One would be negative, one would be positive. So you would start at the negative and end at the positive. So this would be your, if you wrote it in set builder, make sure it's y, not x. And then increasing, decreasing, constant. Well, one, I don't see straight lines, so I know it's not constant. Okay. For our increasing, decreasing, as I'm looking, we'll just separate it. Look at the top part first. As I'm looking at this left to right, what are your y values doing? Increasing. They're going up. But then if I'm looking at this bottom part, as I'm looking left to right and with my x values, what happens here? The y values go down, it's decreasing. But they're increasing and decreasing at the same place. Like the x values are at the same place. So where does it start? Increasing or decreasing? -4. And then where does it stop increasing or decreasing? Infinity. So that was a weird one because normally you won't see something like that because we want our functions to actually be functions facing up, facing down, not sideways. Other questions?
So, quick question. You would be able to find a constant for the one to the left, or to the right, and then down one. That quick.
This one you would have a constant. This one you would not. You don't see any horizontal straight lines. Other general questions? I'm gonna have you guys try some of these so you can get in the hang of writing this in different formats. So on this first page, I want you to try these three: 1, 2, and 9. So first page, 1, 2, and 9. And then on the last page, not the back of the last page, but the front that looks like this. I want you to try 1 and 2. So 1, 2, and 9 of the previous, and then these two. Try those, get it checked, and then if you want to do others, or the dust math, or retake work, or finish your test, then you can do that. So do those 5 and get those checked. Let me know if you need my help, have questions, or if you finish those.